Alright, let's get into it. Number 10. Duale. Sometime in the 13th century, English surgeons were performing operations on fully unconscious patients. Not patients who had fainted from blood loss, not patients restrained by force. Patients who had been given a drink had fallen into a deep, controlled sleep and could be cut open without waking. This was centuries before ether, centuries before chloroform, and the recipe was written down in a manuscript that still exists today. The formula appears in Bald's Leech Book, a medical text compiled around 900 to 950 AD, now held at the British Library as Manuscript Royal D17. It is one of the oldest surviving medical texts written in Old English, and it contains something that should not be there, a surgical anesthetic. The ingredients included hemlock, henbane, opium from white poppies, mandrake, bryony, bile, and lettuce juice, combined in wine and administered as a drink before the operation began. What makes Duale genuinely unsettling is that modern pharmacology has confirmed it would work. The combination of henbane and opium alongside mandrake creates a real synergy of CNS depressants and anticholinergic compounds that would produce genuine unconsciousness. Researchers studying medieval anesthesia have verified the pharmacological logic. The formula is not folklore, it is a working surgical sedative, recorded as routine in a 9th century monk's handbook. The problem is the margin. The dose that produces surgical sleep and the dose that stops the heart are separated by almost nothing. A modern anesthesiologist calibrating the same compounds in a controlled laboratory setting with instruments and body weight calculations would still consider this combination dangerous to administer. The same manuscript that records Duale also specifies a waking preparation. Vinegar held under the patient's nose, stimulating the trigeminal nerve to bring them back. They knew the risk. They had a recovery protocol, how practitioners without chemistry, without dosage measurement, and without resuscitation equipment reliably hit that window between sleep and death, and apparently hit it often enough to record the recipe as routine, is a question that modern anesthesiology has not answered. Number 9. Theriac. For more than 1,500 years, from the courts of ancient Rome through the medieval Islamic world and into Renaissance Europe, one medicine stood above all others. Physicians staked their professional reputations on it. Emperors demanded it. And it was so complex to produce correctly that its preparation became a public ceremony performed in city squares so that witnesses could verify it had been made with the right ingredients. The compound was called theriac, and it contained up to 64 separate components. The original formula was created by Andromachus, personal physician to the Emperor Nero, around 60 AD. He refined an earlier antidote attributed to King Mithridates of Pontus and expanded it into a preparation that Galen, the most influential physician of the ancient world, described in detail in the 2nd century AD. From there, theriac moved into Islamic medicine. Ibn Sina incorporated it into his canon of medicine around 1025 AD. Venice eventually became the center of theriac production, and Venetian theriac became a regulated export commodity. The ingredients included viper flesh, opium, cinnamon, myrrh, beaver castor, and dozens of plant compounds. The viper flesh was not symbolic, it was pharmacologically intentional, based on the observation that snakes survive their own venom and therefore their bodies must contain an antidote. The opium served as an analgesic and sedative. The rest of the formula was built around genuine botanical knowledge accumulated across centuries of clinical use. Modern pharmaceutical analysis of theriac's verified ingredients has identified real antitoxin and immunomodulatory properties in several components. The difficulty is what happens when 64 compounds interact simultaneously. Current drug interaction models are not designed to map synergistic effects at that scale. The interactions between a handful of compounds are complex enough. 64 compounds working in combination represents a level of pharmacological complexity that modern science has not attempted to recreate. Theriac was abandoned not because it was proven ineffective, but because modern medicine developed drugs that worked on single targets. A 64-ingredient compound that may have operated on dozens of biological targets simultaneously was simply too complex to study, and so it was set aside. We still do not know what it was actually doing. Number 8. Black henbane. Medieval physicians described black henbane as one of the most dangerous plants in existence. They prescribed it anyway. In controlled preparations, they used it for pain, for sleeplessness, for anxiety, and according to Ibn Sina's Canon of Medicine, written around 10 and 25 AD, for something even more specific, targeted anesthesia of individual body parts, achieved through localized application. The plant that could kill a man in excess was being used, in the hands of trained practitioners, as a precision pharmacological instrument. Henbane, or Hyoscyamus niger, had been documented medically since at least the 1st century AD. When Dioscorides described its properties in De Materia Medica, the foundational pharmacological reference used by physicians throughout the medieval period, its active compounds are hyoscyamin, scopolamine, and atropine, all genuine central nervous system agents from the tropane alkaloid family. Scopolamine, derived from henbane, is still used in modern medicine today in motion sickness patches and pre-operative sedation. The problem that medieval apothecaries faced, and apparently solved, is one that still challenges modern pharmacology. The concentration of active alkaloids in a henbane plant varies enormously depending on soil composition, the season of harvest, the age of the plant, and the specific part used. 2 plants growing side by side in the same garden could have alkaloid concentrations differing by a factor of 10 or more. Medieval practitioners working without chemical extraction, without any means of measuring what was in the preparation they were making, were somehow titrating a compound whose potency they had no way to assess. And they were doing this for patients. The overdose profile of henbane is not gentle. Excess produces hallucinations, convulsions, coma, and cardiac arrest. The plant was implicated in deliberate poisonings throughout medieval Europe precisely because it worked so reliably as a toxin, yet the same apothecaries documented its therapeutic use across centuries of accumulated records. When modern pharmacologists struggle to stabilize scopolamine doses in controlled laboratory conditions, using purified compounds of known concentration, the question of how medieval practitioners reliably extracted and administered a pharmacologically volatile plant without killing their patients becomes genuinely difficult to dismiss as luck. Number 7. The opium wines of medieval Islam. 3 centuries before laudanum was formulated in Europe, Islamic physicians of the 10th and 11th centuries were dispensing opium preparations with dosage instructions so precise and clinical observations so accurate that modern pain specialists studying these texts have described the experience as unsettling. Not because the knowledge is primitive, because it is not. Al-Kindi, the 9th century scholar who died around 873 AD, wrote a text called De Gradibus, in which he attempted something that had never been done before, a mathematical system for quantifying drug dosages. He applied this system to opium preparations dissolved in wine, creating a framework for graduated administration based on the patient's condition and weight. This was not poetry, it was an attempt at clinical pharmacology written in the 9th century. Ibn Sina expanded this tradition dramatically in his Canon of Medicine around 10 or 25 AD. What he documented about opium goes beyond description of its pain-relieving properties. He described with clinical accuracy what we now call opioid tolerance, the phenomenon by which patients require escalating doses to achieve the same therapeutic effect. He described withdrawal. He described fatal respiratory depression, explaining that death came from a progressive slowing of the breath into unconsciousness. The physiological mechanism he outlined would not be formally confirmed by Western scientific methodology until the 20th century. These preparations combined latex from Papaver somniferum, dissolved in wine, reduced to concentrated tinctures that were functionally identical to laudanum, the preparation that Paracelsus would formulate in Europe in 1527 as if it were a new discovery. The 500-year gap between Ibn Sina's documented knowledge and its European reinvention represents one of the most consequential losses in the history of medicine. The most sophisticated opioid pharmacology in recorded history was written down 1,000 years ago, partially translated, partially read, and then forgotten. Some of what was discovered about pain management in the 20th century had already been known, documented in extraordinary detail, and lost. Number 6. Mandragora. The instructions for harvesting mandrake root in medieval herbals are so elaborate, so ritualistic, and so apparently irrational that scholars dismissed them for centuries as pure superstition. You were told to harvest at night. You were told never to touch the root directly with your hands. You were told to tie a dog to the plant, retreat to a safe distance, and allow the animal to pull the root from the earth while you covered your ears against the death shriek the root would release as it came free. Modern ethnobotanists spent decades treating these instructions as folklore. Then pharmacological research began to suggest something more troubling. Mandragora officinarum appears in Dioscorides de Materia Medica in the 1st century AD, and runs continuously through medieval botanical literature, including the Hortus Sanitatis published in 1491. Its active compounds are scopolamine, hyoscyamine, atropine, and mandragorine, a genuine array of potent central nervous system agents. Medieval physicians prescribed it as a sedative, an anesthetic, and a treatment for melancholy. They were right about its pharmacological effects. They were also right to be afraid of it. The nocturnal harvest instruction encodes something real. Some ethnobotanical researchers have proposed that alkaloid concentrations in mandrake fluctuate with conditions that vary across the day, making timing of harvest a genuine pharmacological consideration rather than a ritual one. The instruction to avoid skin contact is unambiguously correct. Tropane alkaloids are absorbed transdermally. A practitioner harvesting mandrake, root by hand without protection, would absorb a significant dose through the skin of the palms, which are highly vascularized. The warning against handling the root was not mysticism, it was occupational health guidance. The Shriek Protocol encoded the most important warning of all: leave before the root is free. The instruction is irrational as written. As a safety protocol, it makes complete sense. Move away from the source of exposure before the root is disturbed. The mythology was the only available language for pharmacological safety instructions in a world without chemistry. If medieval herbalists encoded genuine chemical safety protocols inside ritual and mythology because they had no other framework to transmit them, how many other apparent superstitions in ancient pharmacology are actually instructions we have never learned to read? Number 5. The Assassin's Hashish. In the mountain fortress of Alamut in northwestern Persia, sometime around 1090 AD, Hassan-i-Saba founded a military and religious order whose members demonstrated a discipline, fearlessness, and willingness to die on command so absolute that it shook the medieval world. Crusaders encountered them, sultans feared them. And the explanation that spread across medieval chronicles was pharmacological. These men, it was said, had been given a substance so powerful that it had dismantled their fear entirely, replacing it with certainty of paradise. Marco Polo documented the most complete version of this account in Il Milione, written around 1300 AD. Recruits were allegedly administered a preparation, carried unconscious into a hidden garden of extraordinary luxury, allowed to experience it as paradise, then returned unconscious to their ordinary lives, and told that obedient service was the price of returning there in death. The word assassin has been widely connected etymologically to the Arabic hash-shashin, though modern scholars note this etymology remains debated and the link contested. What is not contested is the order's historical reality or the terror it inspired. The pharmacological problem with this account is significant. Standard hashish, which delivers tetrahydrocannabinol as its primary active compound, cannot produce the effects described. Full amnesia, complete dissociation, the elimination of self-preservation instinct, and reliable behavioral conditioning across multiple recruits. THC does not do these things. Some researchers have proposed that the preparation used at Alamut, if it existed as described, was a combination of hashish with henbane and opium, a blend of compounds capable of producing deep amnesia, vivid hallucination, and profound psychological disruption simultaneously. The Alamut fortress was destroyed by the Mongols in 1256 AD. Whatever texts might have documented the preparation method did not survive. The arcane knowledge of how it was made, if it was made at all, was buried under rubble in the 13th century. Whatever compound was used at Alamut, it produced behavioral outcomes so extreme and so consistent that it built one of the most feared military organizations in medieval history. No modern psychopharmacological preparation has been proposed that fully accounts for the described effects on human will and self-preservation. Number 4. Ergot. In medieval Europe, entire villages would descend into crisis simultaneously, without warning and without apparent cause. People convulsed. They reported visions. Their hands and feet went numb, then darkened, then fell away from their bodies as the tissue died. The outbreak swept through communities and then vanished, leaving the survivors unable to explain what had happened. For centuries, the cause was attributed to divine punishment, to witchcraft, to plague. The actual cause was the bread. Claviceps purpurea is a fungus that grows on rye and other grains, replacing the grain kernel with a dark, hardened body called a sclerotium. Ground into flour and baked into bread, it is invisible. When consumed in sufficient quantities, the ergot alkaloids it contains attack the human body through multiple simultaneous pathways. The gangrenous form of ergotism causes catastrophic vasoconstriction, cutting off blood supply to the extremities until the tissue dies and separates. The convulsive form produces hallucinations, seizures, and psychotic episodes that are clinically indistinguishable from acute psychiatric illness. The first clearly documented outbreak appears in the Annals of Xanten in 857 AD, describing mass death along the Rhine Valley. A major French outbreak in 944 AD killed an estimated 40,000 people. The outbreaks continued sporadically through the medieval period, with victims and witnesses recording experiences that read, with modern understanding, as precise clinical descriptions of ergot poisoning. In 1982, historian Mary Kilbourne Mantosian of the University of Maryland published the hypothesis that ergot contamination of the rye crop in Salem, Massachusetts in 1692 contributed to the behavioral symptoms that drove the witch trials. The geography and the symptoms align. Albert Hofmann synthesized lysergic acid diethylamide, known as LSD, in 1938 at Sandoz Laboratories in Basel, working directly from ergot alkaloids. The most notorious hallucinogen of the 20th century is a refined derivative of the same compound that was accidentally poisoning medieval populations for centuries before chemistry existed to identify it. The same fungus that killed 40,000 people in 10th century France, that may have sent innocent people to their deaths in Salem, and that Hofmann refined into LSD, was growing in the fields of the medieval world entirely undetected, hiding in plain sight in the most ordinary food that existed. Number 3. Bald's Eye Salve. In 2015, a team of microbiologists at the University of Nottingham decided to test a recipe from a 9th century Anglo-Saxon manuscript against one of the most dangerous pathogens facing modern medicine. The recipe was over 1,000 years old. The pathogen was methicillin-resistant Staphylococcus aureus, known as MAR-SA, an antibiotic-resistant bacterial infection that kills tens of thousands of people every year and that modern pharmacology has struggled to treat. The medieval recipe won. The formula comes from Bald's Leech Book, the same manuscript that contains the Dwale anesthetic recipe held at the British Library as Royal 12D Exanthinth and compiled around 900 to 950 AD. The ingredients are strikingly simple: garlic, leek or onion, wine, and ox bile. The preparation method specified in the manuscript was precise. The ingredients were to be combined in a brass vessel, left to steep for 9 days, then strained. Dr. Freya Harrison and her team at the University of Nottingham Centre for Biomolecular Sciences followed the original instructions as closely as possible. The results, published in 2015 and subsequently replicated, showed that the preparation killed approximately 90% of MRSA bacteria and biofilm, a performance comparable to or exceeding the antibiotics currently used against the infection. This was tested not just in laboratory conditions, but in mouse wound models, bringing it one step closer to clinical reality. The preparation outperformed its modern equivalents against one of the most intractable bacterial threats in contemporary medicine. The most significant finding was not the kill rate. It was what happened when the researchers tested the ingredients individually. Garlic alone did nothing significant. Onion alone did nothing significant. Wine alone, ox bile alone, the brass vessel alone, each component tested separately, produced no meaningful antibacterial effect. It was only the specific combination, prepared by the specific method, that worked. The 9th century compiler had not stumbled onto one active ingredient. They had encoded a precise synergistic formula whose mechanism modern chemistry is still working to reverse engineer. A monk copying recipes into a leather-bound manuscript in 9th century England recorded a formula that defeats antibiotic-resistant bacteria, and modern science, with every analytical tool available to it, still cannot fully explain why the combination works when the individual parts do not. Number 2. The flying ointment. In the records of witch trials conducted across Europe between the 14th and 17th centuries, accused practitioners described the same experience with a consistency that inquisitors noted but could not explain. A preparation was applied to the skin, typically at night. Within a short time, the sensation of flight began, a visceral, embodied experience of leaving the ground, traveling through darkness, arriving at a gathering, and returning. The church recorded these accounts as evidence of diabolical delusion. Pharmacology, examined carefully, suggests something more precise than that. The ingredients of the flying ointment appear consistently across trial records, demonology texts, and early modern pharmaceutical literature. Johann Weyer, a physician who documented them in De Prestigiis Daemonum in 1563, and the authors of the Malleus Maleficarum in 1486, both recorded formulations built around the same core plants: belladonna, known as Atropa belladonna, henbane, mandrake, and hemlock, combined in a base of rendered animal fat, typically lard or tallow. All 4 plants contain tropane alkaloids. The fat base enables transdermal absorption, delivering the compounds through the skin and into the bloodstream without passing through the digestive system, which would degrade some of the active components. In 1960, German pharmacologist Gustav Schenk self-administered a reconstructed flying ointment preparation and documented the experience in his subsequent writing. He reported a powerful sensation of flight, extreme hallucinatory visions, and significant cardiovascular effects. His account, while not a controlled clinical trial, matched the historical testimonies with a precision that was difficult to attribute to coincidence. The pharmacological mechanism he experienced is explicable. High-dose scopolamine produces vestibular disruption, dissociation, and vivid hypnagogic hallucination. The sensation of flying is a documented clinical effect of scopolamine intoxication. Scholarly interpretation of the historical accounts has suggested that the transdermal route of administration was not accidental. The mucous membrane tissue in certain areas of the body absorbs compounds more efficiently than standard skin. Applied to the right surface, a fat-based preparation containing concentrated tropane alkaloids would deliver a dose far more effectively than oral administration, while also bypassing the emetic effects that would otherwise make the dose intolerable. The women who used these preparations appear to have known this. The flying ointment was not a metaphor, and it was not a confession extracted under torture from women who had never touched a plant in their lives. It was a real pharmaceutical preparation using an optimal delivery route, producing a real and predictable pharmacological experience, and the knowledge of how to make it was being practiced by women who understood its properties well enough to replicate the results. What was burned as witchcraft was, in pharmacological terms, applied chemistry. Number 1. Mithridate. Around 120 BC, a boy became king of Pontus, a kingdom on the southern shore of the Black Sea in what is now northern Turkey. He had watched his father die by poisoning. He was surrounded by enemies who would kill him the same way if given the chance. And so, according to accounts recorded independently by Appian, Pliny the Elder, and Plutarch, he began a project that has no parallel in the history of medicine. He started poisoning himself. Every day, in doses calculated to be just below lethal, he administered every known toxic substance to his own body. He intended to make himself impossible to kill. Mithridates VI of Pontus ruled for more than 60 years, from approximately 120 to 63 BC, and the project never stopped. The personal antidote he developed, called Mithridateum, was recorded by Pliny the Elder in Naturalis Historia as containing 54 separate ingredients, including viper flesh, opium, castoreum, cinnamon, and myrrh, alongside dozens of botanical compounds. This was not simply an antidote to be taken after poisoning, it was a daily preparation, a pharmacological maintenance regime designed to keep his tolerance elevated against the entire known spectrum of toxins simultaneously. Pliny described it with enough detail that the formula survived, was copied by Andromachus into the compound later known as theriac, and continued to be produced and prescribed in Islamic, Byzantine, and Western European medicine continuously until the 17th century. The account of what happened in 63 BC, when Roman forces under Pompey finally defeated him, is recorded in multiple independent ancient sources. Mithridates, cornered and facing capture, attempted to die by his own hand. He administered poison to his daughters first, and they died. Then he drank the same preparation himself. It did not work. He could not die. A poison that killed his daughters in minutes had no effect on a man who had been metabolizing toxins as a daily practice for 6 decades. He was eventually killed by a soldier at his own request by the sword. The pharmacological principle at the heart of this account is real. Mithridatism, the induction of tolerance to toxic substances through repeated sublethal exposure, has been confirmed in animal studies for individual compounds. The immune and enzymatic systems of the body do adapt to repeated chemical insults in ways that can produce genuine tolerance. The question, the one that modern toxicology has never resolved, is not whether the principle works. It is whether a human being can achieve simultaneous tolerance across 54 distinct toxic compounds through a single graduated exposure program, and whether one man's lifetime of self-poisoning could have actually made him immune to everything. No modern medical institution has attempted to find out. To test the claim would require doing precisely what Mithridates did, systematically administering toxins to a human subject over years, escalating the doses, and waiting to see what survives. It is not an experiment that can be run. And so, the central pharmacological achievement of the most ambitious self-experiment in the history of medicine remains unverified, not because the science disproves it, but because the science will not test it. Mithridates VI spent his entire life trying to become something that humanity has never managed to create since: a body that chemistry cannot touch. Ancient sources from 3 independent traditions record that he succeeded. Modern toxicology confirms the mechanism is theoretically possible, and the formula he used was considered credible enough that physicians prescribed variations of it for 1700 years after his death, the longest-running drug in the history of medicine, built by a king who was afraid of being poisoned and who decided, with extraordinary and terrifying logic, that the only solution was to become the poison. If you want to see more videos like this, click the video on screen now and make sure to subscribe.